Okay, so let's see. Go.
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 Let's
Here we go.
go.
Not go. Go.
Go.
Right, let's see, where were we? We did this. We did this. Didn't we? Yeah, we did this.
Yeah.
Did we do this?
No,
No, we're continuing from here.
How much long should I live?
Well, this is 5 of 13.
Just half a page.
So,
So when?
Half a page. A page.
a page, yeah. Page. Yeah. Why do you need to leave space?
I didn't attend the last class.
Oh, you want to know how much was in the first part? Oh, not much. Yeah, so you were saying it was half a page for you.
Yeah.
Yeah, he needed...
Just half.
Yeah, so this is probably enough. Yeah, so just start here.
Okay.
Yeah. You didn't watch the video?
No, because I moved house whole weekend.
You don't have internet in your new house?
What? Oh yeah, we have.
Yeah.
But it's whole weekend I'm doing the tidying.
Okay. Right, we'll continue now. So, oh, how's your foot? You hurt your foot?
It's okay.
It's okay?
It's not swollen anymore.
It's not swollen? That's good. Okay. Right, internal energy U. And this is for a material, could be solid, liquid, or gas. It's the sum of the kinetic and potential energies of each molecule. So that is, it's the total heat, which is equal to the kinetic and potential energies of the molecules. So as a formula, it's simply U equals all the energies. And all the energies are all the kinetics plus all the potentials. So if you had something like this, sigma, you know this one, yeah. So if you have this here and they're moving around, okay, they all have kinetic energy and they all have potential energy. So U is the total energy, which is all the kinetics plus all the potentials. Okay, and this is actually what we mean when we say heat. Yeah, so okay, if you write this box down carefully.
But what is I?
Oh, I just mean like, you know, x1, x2, x3. So that's what I mean when I just say I.
Okay.
Count all of them. No, come on, English. What
Read
did you
all
say?
of them? All the box?
I think that would be good. Good for your English.
Oh, Stephen.
Yeah.
Question. how about the computer system?
Yeah,
The subject in the university
it's good. Yeah.
is good. It's about how to use C language or Python.
Yeah, it depends which computer system class you do.
Yeah. And what's the difference with the other subject, like the computing, the counting?
Counting?
Yeah, counting.
Counting?
Yeah.
What do you mean?
There are many subjects beginning with the counting and the
Counting?
yeah.
Are you sure?
Computing.
You mean computing?
Computing.
That's very different to counting.
Yeah. Sorry.
Yeah.
Yeah.
Well, no, it depends, Summer, because there's so many computer classes.
Yeah, I know.
My advice,
Yeah.
if you were doing a computer class at university,
Yeah.
is you should study security, computer security. Yeah.
It's
Protection, hackers,
Yeah.
virus, this type of stuff.
in the internet safety.
Internet safety, yeah. There's good jobs and good money for this qualification. Good jobs and good money for this security. Yeah? Okay, you got that? Yeah.
Nearly.
Nearly, okay. You have that, Ben? Yeah, Khalifa? Go?
Okay.
Yeah, continue, so. Now, heat, you know this word heat, of course. Heat. Heat is a type of energy. It's not physical. Heat has no mass. But heat can move from one place to another place. In thermodynamics, heat means energy, which means moves between two things. So, for example, my coffee is hot. It has heat. The heat moves from the coffee to my hand. I can feel it moving. Yeah?
Yeah.
Heat is not the same as temperature. Okay? This word heat and this word temperature, they're not the same meaning. The temperature of an object measures the average speed. So the speed of the molecules. So if the temperature is big, it means the molecules are moving fast. Yeah?
Yeah.
Good, okay. This means, so be really careful with the English, this means a swimming pool, you know a swimming pool?
Yeah.
At 20 Celsius has more heat energy than a cup of coffee at 80. Okay? Because heat is the energy. I know the coffee is hotter, but it's so small.
Yeah.
The swimming pool has more heat energy, even though its temperature is less. Are you okay with the English here?
Yeah.
Yeah, are you sure?
Yeah.
Yeah. Okay, so heat or thermal energy, a few properties. It can be transferred from one body to another, so you can move heat from here to somewhere else. You can measure it mathematically, and it's not a material, because you can't change heat into something else. You can't change heat into a pen. You can move heat, but you can't change it. It's always heat. And heat is a type of energy. Okay, now I need you to write this, but you don't need to write the whole box. So for example, here you could say heat may be transferred. Or here you could say you can measure it. Here you could say it's not a material. And here you could say heat is a form of energy. You don't have to write the whole sentence. You understand? Yeah? got that, Gav?
Is that post, the post, if I post a letter, is saved?
Oh yeah. Well, what will you put in it though?
Passport. Except for, I made a mistake today. I forgot the registered post.
That's okay. That's okay.
So I don't have
Just-
receipt. I can't track the letter.
You can't track it. Yeah, normal post. It's safe here. It's safe here. Do you put your address on the back of the envelope?
On the top.
Yeah, your address is on the top.
No.
Oh, you don't write your address on it too?
No.
You just write one address, not two addresses. Ah, you should really learn to write two addresses.
But inside is passport and a GIB card and the form of the.
Oh, okay.
reaction.
Okay. No, because it's safe, but I always write my address on the back because if I make a mistake and it doesn't get to the right person, it can be sent back to me.
But okay, but address is correct, I think.
Okay, yeah, because
analyzed.
it's yeah. Okay, so there'd be no confusion. There's only one
Yeah.
immigration office in Dublin,
Yeah,
so there's no confusion then. Yeah, okay, yeah.
It's okay, isn't it? Even though I didn't register it.
Yeah. It's okay. Yeah. Like I've done this before. Just use normal post
Okay.
because I think when they send the passport to me, it's just by normal post. It's not special post, you know.
Okay.
But in future, it's good to put your name on the back of anything you post because
And
if
my
it gets
address.
lost,
Okay.
it can come back to you.
Okay.
Yeah. Because maybe when you write the address, you don't write it clearly. But this is okay because INIS Dublin is quite clear, and they would have many letters, so many people would know this place. You know. When did you post it?
This lunchtime. Today lunchtime.
Okay, so
In
so-
the corner. In that one.
yeah. So they'll pick it up this evening. So it might be there tomorrow or Wednesday. Yeah. Okay. Right. The heat supplied, called Q, this is how much energy you pump into the system. So what I mean is, here's my coffee, and imagine I put some heat under it to make it warmer. Yeah? I call this heat supplied Q. So the heat I put into it, I call that Q. Do you understand? Yeah, so heat supplied Q is the energy. Do you know what I mean when I say pumped?
And bumped.
You know, bumped. Yeah, it's not quite this. What would you say pumped is?
Like pressure.
Yeah, like pushed into it.
Applying pressure.
Yeah, you know, like forcing the heat into it. Are you looking the word up?
It's not that correct.
Huh?
It's not that correct. I don't understand Chinese.
What
The
did
dictionary.
what did the Chinese say?
They say like that's it.
Huh?
I get something from inside to outside.
Pumped?
Pumped into.
Yeah, it depends.
Yeah, well, it depends how you use it. So, pumped into means you put something from the outside
To
inside. Yeah,
Okay.
yeah. What's wrong with the word?
No. 臭吗?
Do you know this word?
No, that means give, just give.
臭不容易臭.
No.
I misunderstand in Chinese.
Her Chinese is very bad.
对这个对我手是臭.
Here,
Oh, yeah.
let me check here.
I won't understand.
But I see here in English.
Yeah. But in the other, they'll have two
Yeah, well,
meanings.
like it's like this meaning here. Can I open this one? Like more?
More?
Yeah. Where's it gone?
No.
More?
Go back.
Yeah.
I think how I use the word is like this one. It says, because short of funds, many universities, in order to encourage more for each of the, and then it goes on to say they'll put more money in. So I think it's like the meaning of this word.
Sorry.
You see, you can't.
Oh, come.
It can't. Yeah. Is this pumped in Chinese?
But this means
Yeah.
From inside to
yeah,
outside.
from inside.
Oh
Yeah.
no, not this.
Yeah.
Not this. No, outside to inside
Yeah.
is what we mean here. Okay. Did you write this down now? Heat supplied. You got this, Ben? What class did you have this morning?
EAP.
EAP. Just EAP?
Yeah, just the history class.
You had chemistry?
No. Before.
Oh, just before this one.
Before this one, yeah.
What time was EAP at?
9?
to 12.
Big days then.
Yeah.
But we only have 2 class for EAP. Because Neil have some meeting, I think.
Oh, normally you have, what, 3 classes?
Yeah.
Yeah.
Finish at 11 today.
That sounds so boring. 3 classes of EAP.
Yes.
So boring.
Yes.
And we have essay for EAP. Now it's 2 essay for EAP. But it's
Yeah.
short one.
Okay.
Short one.
2 essays. That's also boring.
Mm.
Alright, you got that?
Yeah.
Khalifa? Yeah. Okay. For example, a train engine, you know a train?
Yeah.
Its engine works because it gets heat from the burning of coal. This heat is converted into work. So, like if you have your train, there's my train. You have heat that's put into it when you burn, the coal, and it makes the fire.
Yeah.
And this heat is what makes the train move. So you can change the heat into work then. Okay. Now, more definitions, I'm afraid. 2 systems are in thermal equilibrium if no heat flows between them when connected by a path permeable to heat. What does that mean? Let me explain. So, if I put my hand against my coffee, I can feel the heat move from my coffee to my hand. Now, if I put my hand against my other hand, I don't feel any heat. The heat doesn't move. Right?
Yes.
Yeah.
Does this hand...
Yeah.
Yeah?
Yeah.
Why is this so surprising?
It depends.
They're at the same temperature, so the heat doesn't move.
Yes.
What?
Yeah. Because in the normally
Yeah.
in the daily life,
Yeah.
our thing, so we will feel the heat, but no.
Yeah, you can't feel it yourself
Yeah.
because they're the same temperature. Yeah. So even though they're connected by a path permeable to heat, this means the heat could travel, but there's no heat that travels. Well, here, look, if I put my hand here and here, the heat could move because they're touching, but it doesn't move.
Because
But if I put my hand here and here, the heat could move, and it does move from here into my hand.
So how about 2 hand is different temperature?
Well, when will that happen? Oh, well, I suppose if I put one hand here for a while, and then if I put them together, this will feel warm.
Yeah.
So the heat moves from here to here.
So it's no
Okay.
heat?
No, what we're talking about is thermal equilibrium.
Oh.
So if the heat doesn't move, we say that thermal equilibrium.
Okay.
Is this thermal equilibrium? No,
no.
because the heat is moving from my coffee to my hand. Okay. Now, what about if I put my hand on like this? No. Which way do you think the heat is moving?
Your hand to the
From
wall.
your
Hand to the wall. I can feel it moving. Okay? But if I put my hand on the table, yeah, I guess I can feel it moving to the table as well. If I put it on my face, I can't really feel any movement. Yeah?
Yeah.
No, you can't feel any movement, right?
Yeah, I can
Yeah.
feel because my hand is cold.
Your hand's cold, okay,
Yeah.
right. Well, if you were outside, this is true. Okay. What about with the plastic? Yeah, it feels a little cold. Okay, so this is thermal equilibrium.
So it must
Basically, it means the same temperature.
I mean, you every heat need to touch.
Huh?
Touch.
Yeah. Oh, yeah, that's what it means. Connected by a path permeable to heat means if they're touching
Yeah.
and no heat moves, then we say it's thermal equilibrium. You remember this word equilibrium? Balanced, yeah. And thermal means heat.
Heat.
So it's like balanced heat. Yeah, it's okay. Khalifa, it's okay. Yeah, did you write it down? Got that? Somewhere it's writing. You're writing so slowly today.
Because
You're cold.
no, I'm talking with you.
You can do both, can't you?
Okay. Alright.
Continue.
Yeah.
Basically, if two bodies are the same temperature and no heat flows, then they're in thermal equilibrium. Okay. Right. Here's a very simple engine. Very simple. So Q is the heat pumped into the engine from the coal. So you see here you have lots of heat. This heat goes into the engine. That's the Q. Yeah. This delta U is the change in internal energy. So what happens to this water? It gets hot. Yeah, it turns into steam. Okay. W is the work. What is the work? The train moves. Okay. Now, I want you to try and write for me a formula for these three. I want you to try and figure out what a formula is. You know, is it, for example, this equals this equals this? Or maybe this equals this plus this? Do you understand? I want you to think for a minute and try and give me a formula for these three. Do you understand what I'm asking? Do you understand what I'm asking?
You just try to write down the formula for this tree.
Yeah, relationship for the tree. And just, I'll say it again, the Q is the heat, okay? The delta U is the extra energy in the water and the engine. And then the W is the work that the train does.
Q
equals
Delta.
Delta U plus W.
Good, good. And what rule gives you this in physics?
The energy wouldn't be.
Yeah, what's this
Oh,
called?
Destroyed.
Yeah. Oh, yeah. What's this rule called?
Energy.
Energy.
It's called the conservation of energy.
Conservation.
Yeah. It says energy can't be created or destroyed.
Destroyed.
Conservation of energy is what it's called.
Conservation.
Okay?
Okay.
Right. The conservation of energy states that Q equals delta U plus W. Oh, your English, this is We really need to do something about your English. Did your English teacher talk to you about your physics?
Yeah.
And what did they suggest you do?
It's the same as EAP.
Yeah.
Yeah, which is what?
Just
Just the
have the
right,
word.
Yeah.
Yeah, and are you doing this?
That's the first physics class after this.
Is it? Okay, fine.
Okay.
Okay. Right. Now, James Prescott Joule. In the last picture, what happened? We put heat in and we got work out. Do you understand? Heat went in and work came out. Yeah. Heat was pumped in and work came out. Okay. James Prescott Joule, he wondered if you could do it the opposite. Could you put work in and get heat out?
Mm.
So, yes, he did this, and I'll show you the way he did this. Very old experiment. Okay, I got a picture here. So, can you see this picture? I'll explain what's in the picture. This here is a thermometer. What does a thermometer measure? Measures temperature. Measures temperature. Okay. This here is a weight. This here is a wheel. This is a string. Okay, and can you see that this is wrapped around here?
Mm.
So what happens is this falls slowly, and then this moves around as it falls, and these two paddles, they're in the water, they turn in the water.
Okay.
Okay, and here you get the water will be warmer. So what happened is the potential energy here converted into kinetic energy, converted into heat. You understand? So the work was converted into heat energy. So this is the opposite to the last picture. So you can put heat in, get work out. Or you can put work in, you can get heat out. You can go both ways. And what rule in physics says we can go both ways? Conservation of energy. It's the same rule. You understand? Okay. So, yeah, I don't think we need to do this. Okay. Yeah, that's okay. Right, so now we're nearly at the end here. We have some laws of thermodynamics. So we have 3 laws for this lesson. The first law is not called the first law. It's called the 0 law. So we don't go law 1, 2, 3. We go 0, 1, 2. And the reason for this is because this law is so basic. We call it 0. So basic. So the 0 law says, if 2 thermodynamic systems are in equilibrium with a third, then they're in equilibrium with each other. Let me explain that. So here is A, and here is C. And if I move C to be beside A, there's no flow of heat. So it means they're at the same temperature. Okay? Here is B, and here is C also. And again, there's no flow of heat. Therefore, if I put A and B together, will I get flow or no flow?
No.
Also,
No.
no flow. It's like saying, if the temperature of A equals the temperature of C, and the temperature of B equals the temperature of C, therefore, temperature of A is the same as temperature of B. I think we can agree that's very basic rule. This is why we call it the 0 law. Okay, so I'll let you write this one down. Okay, you got that first one? Yeah. The next law, the first law of thermodynamics, is a version of the conservation of energy, which says that U equals Q minus W. Now, you understand that that's the same as what you wrote earlier.
Yes.
I just brought the, what did I do? You said Q equals U plus W, delta U plus W, didn't you? Usually people write the law like this. Delta U is Q minus W. The reason for this is because the Q is easy to calculate, the W is easy to calculate, but the delta U is difficult to calculate. Because remember, the formula for U is this. It's quite difficult to calculate, so this is the usual way to write it. U equals Q minus W.
How do you calculate Q?
You can't. Oh, the Q. Oh, we'll see how to do that in a different lesson. For example, if the Q is coming from an electric heater, then we can just read information on the heater and calculate it this way.
So just write the formula.
Yeah, but you can write the formula, yeah, but write that it's the first law.
Okay.
Yeah. Got that? I think I can just put the next rule up on the board. So the next one, the second law. Now let me explain what it means. It says that heat cannot spontaneously. Does anyone know this word, spontaneously?
That's we guess.
Go on.
We like the push.
What do you think it means?
The sentence means the heat can't be the heat from the cold one can't be give the warm one.
Correct. That's what the whole sentence means, yeah. What does the word spontaneously mean?
Just the give.
No, nice try, but it doesn't mean this. It means heat cannot suddenly, suddenly, like by itself, cannot flow from cold to hot without work being done. So for example, I'll draw a picture here. If this is cold and this is hot, and I move them together, which way will the heat move? The heat will move this way.
Yeah.
The heat cannot move this way unless I do some work and I move it. Okay, so for example, maybe you have here, sorry. This water, and there's a door here, okay, and this side we'll say is 10 Celsius and this side is 90 Celsius, okay, and I lift this up. So which way will the heat move?
No.
The heat will move obviously to the left. If I want the heat to move to the right, I must have some kind of special machine here, and this machine will only let the heat move from left to right. But this machine will need me to do some work, you know, like I'll have to connect it to, you know, some power supply. It doesn't happen for free. naturally it moves from hot to cold. If I want to move from cold to hot, I'll have to do some work, like I'll have to move the heat myself. Yeah.
But how about if you put ice on the drink? Is that cold too hot?
Yeah, no, if this is a hot drink and this is ice, what happens is the hot drink, the heat flows from it into the ice.
Or make ice melting?
That makes the ice melt. Yeah.
But water, the drink getting cold.
Yeah, let's just be clear about what's happening here. So let's say that this is at 20 Celsius and this is at 0 Celsius. And here's you. Okay? And your mouth is at 20 Celsius as well. If I put the ice in here, the heat flows from this into this. True? Yeah, okay. So now, what does it look like? It now looks like water maybe at 10 Celsius. And if I put that to my mouth, the heat flows from my mouth into the water. This gives me the feeling that the water's cold. But the heat is flowing from my mouth into the water. And the heat from the water went into the ice.
Okay.
Yeah? If something feels cold, it means heat is coming out of you. And if something feels hot, it means heat is going into you.
Okay.
Yeah?
Yeah.
Is okay?
Okay.
Yeah, okay, so you'll have to carefully write this one down. Sleepy Khalifa. Charged up? Fully charged? Enough. Okay. You have this, Gal? What word are you searching?
By itself.
Spontaneously, yeah. Continue?
Yeah.
Yes?
Yes.
Right, good, that was the last one. Now, have you been trying these at home? Ah, why not?
Not tempted.
Oh, but you need to, because you have an exam, you know. Like, for example, here, page 66. Did you do any of these? Oh, not 66, sorry. Ideal gas law. Ben? Ben? This page, did you do any of these? Summer? Did you do these?
The second one.
Just the second one.
Yeah.
Gal? Did you do these? How many did you do? None?
I didn't listen.
Khalifa?
Yeah. But the second one,
What? English? What? What's going on?
I said that's 2 pages, there's no half page.
no, just this.
That's for this lesson. How many lessons did you miss?
Just this.
Okay.
The last class we just have this.
2 lessons.
2 lessons, okay. Did you do this one? Summer, Joe, Ben, Khalifa, everybody, please. Please.
Yeah.
Look at me. I'm trying to figure out how much you've done or not done. So, states of matter. Have you done these questions? You think so?
Yeah, it's only English in there.
Yes.
Yeah, it's not
Density?
Yeah.
Yeah.
You've done density. Okay. States of matter? Only English. Yeah, okay. And simple kinetic model? Half. And ideal gas law?
One.
None. One.
Yeah.
1 per 1 per
1 in 3. I wanted to do a tutorial, but you haven't done these questions yet. What the heck? Right, look. This is what I want to know. Give me an honest answer, okay? Khalifa, on this lesson, ideal gas law, how many of these 6 questions have you done? None. Ben? 2. Gail? 0.
1.
1. Okay. This is very, very important for the exam. Very important for the exam. Also, it's also important on the chemistry exam. So it's double important. Have you done this in chemistry yet? No. What topic are you doing at the moment?
We don't have new.
No new topic. It doesn't matter. It's not this. Okay. So the person who did the most was Summer? Ben?
No, Ben.
You did 2.
Yeah.
1 and 2.
Yeah.
1 and 2. One is
1.
one we finished in the class.
Yeah, I know. Leave him alone. You did nothing. Yeah. Okay. I really, really, really want you to have these done now, because it's very important for the exam in physics and chemistry.
Okay.
Right? If you how much? Okay, look. Try to get these done in 4 o'clock, before 4 o'clock, and then I want to do them together after 4 o'clock. We can check the answers.
4 o'clock. Oh, big.
13 minutes. Now, if you don't understand the question, just ask me, and I can explain it, and you can try it. So, Gao, were you in this class when we did this formula, PV equals N or T?
No.
You weren't in this class. Are you sure? After this.
No. That's the last lesson here.
Okay, you need to watch this video, okay? It's very important. You must watch this, okay? Very important.
Okay. Is that difficult to understand?
I
don't know, you can ask them what they thought. Was this lesson difficult?
But it's difficult to understand, I think. But if you understand, that is easy.
Okay.
Yeah, yeah.
What?
如果你
What?
He said he said bullshit like that.
True, true.
What?
No, he's right.
I
Okay.
think I'm right.
Maybe you want to copy some of the notes down, Gail. This is the formula you need, okay? Pressure, volume, number of moles.
Number of molecules?
Moles.
More.
Mole.
Moles.
Mole, yeah. This is a constant, 8.31. And this is temperature. In Kelvin.
Yeah.
Calvin.
Kelvin.
Oh, in Kelvin.
Yeah. Okay, try these. Whoa! That's my remote. Khalifa, can you kick this to me?